Hey everybody, in this video we're going to be talking about the algebra and calculus of matrices. The first part with the algebra is going to be pretty much a review, and then I'll just show you some calculus with matrices, which is going to be pretty intuitive. So this is a nice section. So these things we've learned in the past. Algebra that you can do with your matrices, it's basically the same thing with like distribution, associativity, and constant multiplication. So just briefly, if you have matrix A times B, and you multiply by another matrix C, you can associate the other two, like B and C together, find that product, and then times it by A. Left multiply by A. Number 2 here and number 3 are both like distribution. And then number 4 here is if you have some constant matrix K times A, and then multiply that by B, you can pretty much associate A times B, find that product, then multiply by K, or multiply K times B, and then left multiply by A. The only thing to keep in mind here is the following. So the algebra of matrices proceeds much like regular algebra that you know from working with just numbers, except that you should never presume that you can switch the order of matrix factors. So we've talked about that, but just a reminder, when you have two matrices and you're multiplying, like let's say you had A times B, the answer is not necessarily the same if you say B times A. So if you switch the order, and not very often are you going to get the same answer. So don't assume that you can switch the order. Commutativity, which is the property that says you can switch the order, doesn't hold here. Okay, and then the next thing to remind you about is the inverse of a matrix. So an invertible square matrix A has an inverse denoted A inverse, such that when you say A times its inverse, or the inverse times A, you get the identity matrix. And then a matrix that doesn't have an inverse, we say that it's not invertible, or another way to say it is that it's singular. And so for a singular matrix A, the following are true. The determinant of that matrix would be 0. And then if you have the equation A times x equals 0, there are non-trivial solutions. And then also the rows or the columns form a linearly dependent set. All right, so just some things we've talked about in the past, but reminding you about them. And then the new part is calculus of matrices, but you're going to find that it's pretty intuitive. So first, let's just define a matrix function. It's basically just a matrix whose entries are functions. And then a vector function is a vector whose entries are functions. And so if I want to take the derivative of my matrix A at t, I can write that as A prime. And then if it's a matrix, it basically is the matrix where I'm taking the derivatives of the entries. So in other words, the derivative of a matrix function is the matrix whose entries are derivatives. So matrix A prime is the matrix who we're taking the derivative of each entry. Very similar is the integral. So if we have the integral of a matrix, it's the same as the matrix whose entries are integrals. Okay, so we'll look at an example of both of these so you understand it, but it's very straightforward once you see it. So first, some differentiation formulas, and these also should be pretty intuitive as far as what you've seen from calculus. So it's for some constant matrix times our matrix A. If we want that derivative, it's the same as the derivative of A times that constant. If we're adding two matrices and then we find their derivative, it's the same as taking the individual derivatives and then adding. But then look at this last one here. This should look familiar. This is like your product rule from calculus. So derivative of a product of two matrices is the derivative of the first matrix times the second plus the first matrix times the derivative of the second matrix. All right, so let's try out this example. Here's our matrix A and our vector x, and we want to show that x is a solution to this equation where A times x actually equals x prime. Okay, so we're going to calculate both the left and the right side of this equation. Okay, so here's the right side of the equation, A times x. So here's my matrix A. Here's my vector x. And if I just multiply row 1 times column 1, that's going to give me my new row 1. Row 2 times column 1 gives me my new row 2. And after a little bit of simplifying, we get row 1 is negative omega sine omega t. Row 2 is omega cosine omega t. And now we want to show that x prime equals this. So the derivative of x prime, we are given x. So just differentiate each entry. So derivative of cosine omega t is negative sine omega t times omega. So just using your chain rule. And then the bottom one, derivative of sine, is cosine times the derivative of the inside, which is omega. So omega cosine omega t, which equals a times x. So we just showed that x is a solution to this equation. All right, let's try this one. So given this matrix A, let's first find A prime. So the derivative of the matrix is the matrix with derivative entries. So notice all you have to do is to find A prime, the derivative of each entry inside of A. And so just using our regular rules from calculus, we get that A prime has entry 1, 1 is 2t, just the derivative of t squared plus 1. Entry in row 1, column 2 is just derivative of cosine, which is negative sine t. Derivative of e to the t is e to the t. Derivative of 1 is 0. So really straightforward, just differentiate each term when you're finding the derivative of your matrix. And by term, I actually mean each entry. Differentiate each entry. Now let's find the integral of A from 0 to 1. Okay, so very similar in the idea of the integral of the matrix is the matrix comprised of integrals. So each entry is just being integrated. So you just integrate the individual entries using your rules from calculus. And then we have limits of integration, so we're going to evaluate each entry from 0 to 1. And just plugging in 0 and 1, simplifying, we get that the integral of our matrix A, entry 1, 1 is 4/3. The next entry is sine of 1. And then we get e minus 1 and 1. All right, so again, these ideas of calculus with your matrices, it's fairly intuitive as far as what you've learned about calculus in the past. So just apply what you know and just stay organized and you should be fine with this one. All right, pretty short section. That's it. Thanks for watching.